Hello class, today we're going to talk about adding and subtracting mixed numbers. So in order for us to do that, we do have to have a few prerequisites, okay? One of those is, do you understand what a fraction looks like? So in this particular one, what I want you to do is, I want you to tell me, what does 5/8 look like? Draw me a picture on your paper. Pause the video and draw me a picture. In just a few moments, I'll come back and we'll see if your picture was correct. Okay, so let's find out what you came up with. There's two main pictures that people typically come up with, one of which is going to be that of a circle. So we would have a circle, and for 5/8, that 8 on the bottom is going to tell me I'm going to take this 1, whatever it happens to be. In this case, it's a circle. I'm going to chop it into 8 pieces, and what I need to do is shade in 5 of them. So that right there is one representation of 5/8. Another way of drawing this is going to be that of like what I call the candy bar example, or a rectangle. And you can do it many different ways. I choose to split this down the middle and then chop this into 8 pieces again. As long as you chop it into 8 pieces, you're in good shape. That's what that denominator says. And then again, the 5 says I need to take 5 of those. So I need to shade in 5 of those, and that's 5/8. So those are some visual representation to what the fraction looks like, which is really important in order for us to be able to add or subtract them. So let's see if we can actually review what you did back in 4th, 5th, and 6th grade when dealing with fractions. So here are two questions. One's addition, one's subtraction. And in both of them, we have to start off the same exact way. We have to start off by finding a common denominator. We have to make that bottom number look alike. So in this first one, we think to ourselves, 8 and 12. What's the first number that they have in common? Okay, so we ask ourselves, this is kind of what I do, as I look at the biggest one. I look at that 12. And that 12, I ask myself, could I turn that 8 into a 12 using multiplication? And we can't. So then I take that 12 and I multiply it by 2. I get 24. I ask myself the same question. Could I turn that 8 into a 24? And we can. So 24 becomes my common denominator. So now what we do is we've got to change our numerators. So once we find a common denominator, we have to, whatever we did to that bottom number to change it to that new denominator, I got to do the same thing to the numerator. So in this 8, what did I do to that 8 to turn it to a 24? Well, I multiplied it by 3, so I need to multiply this 3 by 3 to get 9. So 3/8 and 9 over 24 are the same exact fraction. They represent the same thing. So then I ask myself the same thing. I asked 12, what did I multiply it by in order to get 24 times 2? So I do the same thing to the 5 to get 10. Now once we've done that, then all we have to do is add or subtract our numerators, keep our new denominators, and of course, simplify. So 9 plus 10 gives me 19. I keep the bottom number 24, and I ask myself, could I divide 19 and 24 by some number, by the same number? And you cannot, so 19 over 24 is a simplified fraction. Now for subtraction, we do everything exactly the same, except when we get down to the common denominator and the numerator part, we're going to subtract our numerators instead of add them. So we ask ourselves the same question. What could I turn that 5 and that 3 into? Okay, for a common denominator. So you go through the 5 times tables. 5 times 1 is 5. Could I turn the 3 into a 5? No. 5 times 2 is 10. Could I turn the 3 into a 10 using multiplication? No. 5 times 3 is 15. Yes, I can do that because you'll notice you're multiplying 5 times 3. Okay, and so when you're doing that, one way you can do it, you can always cross multiply and get a common denominator. It's just sometimes going to be really large. But when you do, all you do is cross multiply your numbers, and that gives you your new numerators. So 4 times 3 would be 12, 5 times 2 would be 10. There's my two new fractions. That always works. It just sometimes gives you a very large number. Take, for example, the first one. If I did 8 times 12, I'd get 96. That's a pretty large denominator when 24 is really the smallest. So now, we look at our numerators, and instead of adding our numerators, we're going to subtract them. So 12 take away 10 gives us 2 over 15, and we ask ourselves the same question. Could I simplify that fraction anymore, or could I divide each of those numbers by a common number? No, you can't. So 2 over 15 is my simplest form. So in order to add or subtract fractions, we know we find a common denominator. We change our numerators. Whatever I did to the bottom, I must do to the top. We add or subtract our numerators. You keep your new denominator. And then last but not least, you simplify. Now, what if we had mixed numbers? What would I do differently? Is there any steps I would add to this in order to do mixed numbers? Yes, we have to take care of that whole number on the outside. So that becomes very important. So if we look at this question right here, we're going to do exactly the same thing that we just did on the last one. It's just we've got to deal with one more step, add in the whole parts. Now, some of you are going to think, oh, no, we can do the popcorn method on that. No, we do not need to change this into an improper fraction, which is what that does. All we have to do is the same exact steps. So step number one is still find a common denominator. So we go through our 4 and our 8, and we start with the biggest one, the 8. Could I turn that 4 into an 8? Yes. So what we do is we write 5 with the fraction bar with an 8 plus 6 with the fraction bar and an 8. Now in the second one, I didn't change the denominator any, so I'm not going to change the numerator any. I'm going to leave the 5. But in the first one, I had to multiply that 4 by 2, so I need to multiply that 3 by 2 to get 6. So now we found our denominator, we've changed our numerators. Now we're ready to add or subtract our numerators. So 6 plus 5 gives us 11. Keep the denominator, which is 8, and then add our whole parts. 5 and 6 gives us 11. Now, if you can get that far, you get at least half the points on the problem, because that tells me you know how to add or subtract mixed numbers. Now we've got to do that last step, simplify. So please make sure you do that. So now to simplify an improper fraction, we have to use division. We have to ask how many times does 8 go into 11? And we know it goes one time. So that 11, I'm going to add a 12 to it. I'm going to turn it into a 12. I'm going to add a 1, and it's going to become a 12. So I take the 8 out of the 11. Okay, so we do 11 minus 8. We take that out. We end up with 3 left over, and we put that back over the 8 because that's our size. And so that is our simplified answer. Sometimes you may have to still simplify that fraction some, but typically you don't. Okay, so in order to add or subtract mixed numbers, that's all you do. Find the common denominator, change your numerator, add or subtract your numerators, keep the denominator, add or subtract your whole parts, and last but not least, simplify. Now we do subtract the same exact way. Okay, now there are a couple different subtractions, and we'll kind of talk about that in a moment. But in this one right here, we start off the same exact way. Every single problem, find a common denominator. So I'm going to go 9, fraction bar, minus 4, fraction bar. And I ask myself, I've got 9. Can I turn that 6 into a 9? No. So I do 9 times 2, 18. Could I turn the 6 into an 18? Yes. So that's my new denominator. Now I change my numerators. What did I do to the 9? Multiplied by 2. So I multiply the 7 by 2 to get 14. What did I do to the 6? Times 3. Multiply the 1 by 3, get 3. Now we subtract. 14 take away 3 gives us 11. 18 and 18, we keep our denominator. 9 minus 4 is 5. Now we ask ourselves, could I simplify the 11 over 18? No, we cannot. And you're done. And that's all there is to it. Now, sometimes we do have subtraction that's a little bit tougher. So let's kind of take a look at this one. So we're going to start off the same exact way. Find a common denominator. Okay, so I've got 4, fraction bar, minus 2, fraction bar. We got 4 and 3. Well, hopefully you know by now the smallest thing's going to be 12 into that. Okay, so we go 3 times 4, so 1 times 4 to get 4. 4 times 3 times 3, you get 9. Okay, so now we've changed our numerators, we've changed our denominators, we've done everything. But now can I do 4 take away 9? I cannot. Okay, so this is where we've got to do, just like we would do in regular decimals or something like that, we got to borrow from the guy next door. In this particular one, though, and this is kind of what we're doing, we're going to borrow from that 4. So that 4 is going to become a 3. But now that 1 that I borrowed, I need it to be in fraction form, and I need it to have a 12 as the denominator. So that really is 12 over 12. So that 3 and 12 over 12 is really that 4, plus the 4 twelfths that we still have. So when I borrow that 1, what this really becomes is 3 and 16 twelfths. So what you really need to remember when you're borrowing is all you do, you borrow from the 4 and you add the numerator and denominator together, and that becomes your new numerator. Now that makes my fraction large enough that I can subtract from it. So now we've got 16 take away 9, where I'd originally had 4 take away 9. So 16 take away 9 gives me 7. We keep our denominator, and 3 minus 2 gives you 1. So this is subtraction with borrowing. So that's one of those skills that you have to know. This is the hardest type of subtraction problem that we have. It's the hardest fraction problem that we have. Now, all of that stuff is stuff that you should have already known coming into my class. So now let's kick it up a notch. What if you have a negative fraction? So now we're going to mix our integer rules and our mixed number rules together. Now what you got to remember in something like this is this number's positive, this number's negative. So what is our integer rule? Signs alike, add. Signs different, subtract. So in essence, this really is a subtraction problem. Even though it says that it's plus, we've got a positive and a negative. They're going to zap each other out. So this negative 3.5 is going to zap out negative, or going to zap out 3.5 of that 8 5/8. So now that we know that we're going to be subtracting, we just follow that procedure. And our procedure still, find a common denominator. Okay, so I've got an 8 there. So could I turn the 2 into an 8? Yes. Okay, I keep the first numerator because I didn't change the denominator. But the second one I multiplied by 4, so I need to multiply this by 4 as well. Now, since my signs are different, we're going to subtract our numbers. 5 take away 4 gives me 1 over 8. 8 take away 3 gives me 5. And the 8 5/8 had a greater absolute value, so my 5 1/8 is positive. That's all there is to it. So let me have you try one on your own. Now this one's subtraction, so if we kind of pay attention to that, what did we do with subtraction? We changed subtraction to addition, next number to its opposite, and then we went back to the addition rules. So now what am I going to do with these two numbers? We're going to add them because their signs are alike. So pause the video, answer this question, come back to me in just a few moments, and I'll tell you what the answer is. Okay, so let's find out how you did. Okay, so since both my numbers are negatives, we're just going to add them together. So I've got a -5 fraction bar plus -4 fraction bar. I've got 5 and 4, so my common denominator is going to be a 20. I'm going to change my numerators. This one I multiplied by 4, so times 4 to get 8. This one I multiplied by 5, so times 5 to get 15. And so now, since my signs are alike, I'm going to add them. So 8 and 15 give me 23 over 20. 5 and 4 make -9. Now I'm going to simplify. So the 23 over 20, okay, I can pull 20 out of that 23. Okay, and I end up adding that 1 into the 9, which gives me a -10. And when I pull that out, I got 3 left over. And what size piece are they? 20s. So my final answer is 10, or -10 and 3/20. And that's all there is in order to add or subtract mixed numbers. Okay, so we got to find a common denominator. We got to change the numerator to match. We got to add or subtract the numerators, keep our new denominator, add or subtract the whole parts, and then simplify. And every once in a while, you got to make sure that you're paying attention to the integer rules also. Even though these aren't integers, they're just rationals, but you could have positives and negatives, and that's okay. Okay, so if my signs are different, I still got to subtract the problems. If my signs are alike, I got to add them and keep the sign of the problem. Okay, so that's what you're going to be doing on your assignment as well. So until next time, I'll talk to you later.